In today's webinar, we're going to be moving on to talk about more advanced features of the EMF. So the first thing I wanted to do is just kind of have a little recap of what we've done in the past. So we had two previous webinars and some homework exercises. And in those webinars, we went through in detail how we manage data in the EMF. So we talked about how data files get imported and then their data sets within the EMF. And we looked at all the different metadata that gets stored for those data sets. And we also looked a little bit at how to view the raw data and then also how to export the data back to files. So what we're going to do today is we're going to talk a little bit more about some things about viewing and editing the raw data, but then we're going to move on to actually doing more analysis with the data. So we're going to talk about what are called QA steps in the EMF, and these are different kinds of analyses that you can run. And so we're going to talk about how you would create these different steps and be able to look at the output and what you can do with the steps and what you can do at the output. Okay, so we already went over the SQL question, and again, it sounds like a lot of people don't have any experience with it at all, which is fine. The EMF is built on a database, and a lot of the power of the EMF comes from having all of your data in a database. And so then that gives you a lot of tools for being able to query the data or summarize the data in different ways. So we're going to talk some about those tools that we have. Okay, so the first thing I wanted to mention was just about viewing the raw data. You had an exercise where you went into this raw data viewer, and so I just wanted to mention a few little navigation items in here. So we know that these inventory files can have a lot of data, millions of lines of data, and we don't want to be transferring all of that at one time. That would be a lot of data to go back and forth. So the raw data is actually going to be displayed in pages of 100 records. So what that means is each page in this data viewer is 100 records, and there's a navigation widget that I've circled in the diagram here that lets you page through the data. So you'll see a line that says current, which is displaying the list of which is telling you the list of current records. So in this case, we're looking at records 1 through 100. And then there's also a little status line that'll tell you if you have any filters applied and how many records are being filtered. And then we have some forward and back arrows that will let you jump forward one page or back one page, and also the double arrows let you jump to the first and last pages. And then there's a slider where you can grab the handle of the slider and drag it around, and that'll show you what data number, the record number in the box it'll show you, so then you can jump straight to the thing that you're interested in. And in today's homework, you'll have some exercises where you'll get to play with this in your system, and you'll see how it works. There's a couple other features of this data viewer I wanted to mention. First is the sort ordering box. Now, unlike a lot of the other windows in the EMF, you can't just click on the headers of the columns to sort. You actually specify the sort order by typing in the string. So in this case, we're sorting the columns by FIPS, the values in the FIPS column, and then the values in the SCC column. So it's FIPS, SCC. If you need to sort the things by descending order, then there's a keyword descending, which actually it's DESC, desk, which flips the order around. And again, you'll have an exercise in the homework, so you get to see how that works. And then in this screenshot, I'm also showing a row filter, and we're going to talk about the row filter syntax on the next set of slides. In this case, what I'm doing is I'm doing a row filter where I'm filtering so that I'm only showing rows where the annual emissions, so that's this AN emis, that's the column name, where the annual emissions do not equal 0. So I'm just filtering out all the records where the annual emissions are 0. And you can see over in my filter here that I did have a good number. I had probably about 20,000 records where the annual emissions were 0. All right, so let's talk about this row filter. And the reason that I'm mentioning this, and we want to talk about it in some detail, is that you will see this same syntax in a lot of places in the EMF. I have a slide in just a couple slides that actually just lists out some of the places that you'll see this same syntax. And you've run into it in some homework assignments, and you'll have more to do with it in today's homework assignment as well. So first I just want to go over some examples, and then I'll talk about the actual format and syntax. So for example, if we want to display the rows where we have a particular SCC, so we want any row where the SCC is exactly this string, the row filter that we would use would be SCC equals and exactly the string. So SCC is the column name, the operation we want to do is an equals, and then this is the value, this string is the value we're going to match against. Now this is an exact match, so it's only going to match SCCs that are exactly that string. If instead we wanted to do something a little more flexible, like if we wanted to do something where we want to display rows with our sources in North Carolina. So what that means is our FIPS codes are going to start with the characters 37, because 37 is the state code for North Carolina. In that case, we're not going to do an exact match, because we're not matching exactly the whole FIPS code. Instead, we're just matching the first two characters of the FIPS code. And so instead of using an equal sign like we did with the SCC equals, we can use the operation like. And what this means is we want to find data from the FIPS column that's like our string 37. And the percent sign here is our wildcard character. So what this means is my string needs to start with 37, and then we have the wildcard character. Anything after 37 is okay. Now, one thing that's possibly confusing is there are multiple ways to achieve the same outcome. So I just mentioned this FIPS like 37. Well, another way that we can do it is by creating a substring of the FIPS, and then we can do an exact match, because we know that we want it to exactly match 37. So this second line where it says substring, that's an alternative to using the FIPS like. And what this is doing is we're running the function substring on the column FIPS. And the arguments here are, where do we want the substring to start from, which is position 1. We want to start at the beginning of the string. And how long do we want the substring to be? We want it to be 2 characters long. So we're going to take the FIPS code, and we're going to grab the first 2 characters of it, and then we're going to exactly match that to 37. And that will also give us all the rows where the FIPS code starts with 37. Now, besides string stuff like we've talked about with SCC or FIPS matching, we can also run filters where we're filtering the emissions values, for example. So in this case, we have a filter where we want to display the rows where the annual emissions are greater than 1,000, greater than or equal to 1,000, and less than 9,999. So this is a compound statement where we're saying the annual emissions, so the AN emiss is the column that holds the annual emissions values. We're saying that the annual emissions are greater than or equal to 1,000, and the annual emissions are less than 10,000. And so that will give us all the emissions between 1,000 and less than 10,000. Now this AND means we need to match both criteria. There's also the option of OR, where you would match either criteria. In that case, that would give us all the emissions, basically. If this was an OR case, you'd be finding all the emissions that are greater than or equal to 1,000, or all the emissions that are less than 10,000, which would end up covering all values. So just to be a little more generic about what this row filter does, like we talked about, we can use it to filter the rows that are displayed based on your criteria. So the example I showed of the inventory data set had about 150,000 records in it. And so if you're only concerned about the records for a particular county, or maybe a particular source category code, source classification code, the SCC, then you can use a row filter to narrow down exactly what you're looking for. the basic format of this row filter, as we saw in the examples, is that you're going to give it a column name, you're going to give it an operation, and then you're going to give it a value. So in one of our examples, we gave it the column name SCC, we gave it the operation equals, and then we gave it the value of the exact SCC that we wanted to match. And on the next slide, I'm going to talk more in detail about what those different parts, what all your options are. And then I mentioned how you can have multiple criteria with the AND or the OR, and how AND is going to match all the criteria. So like the annual emissions being greater than 1,000 and less than 10,000, or which would let you do something like find me all the rows where the SCC is this SCC or some other SCC. And then the syntax is like a where clause in SQL. What's really happening is when you write a row filter, you really are writing part of the where clause that's going to run on the underlying data. So if you know anything about SQL, or if you get a chance to learn more about SQL, you'll notice that this is just like a where clause. Okay, so then just some more details about what these different parts of this expression, this row filter, can be. So we talked about the column name, and this can be any column name that's in the data set, or it can be a function that uses the column names. So like we saw an example of substring of FIPS. So we were using the column FIPS, and then we were using a function that works on that column. And these column names are not case sensitive. So you'll see the column names are usually capitalized in the data sets, but you don't have to worry about your row filter. You don't have to worry about the capitalization. And so then some examples of what you might see as column names. We saw an example with SCC. Pol, for pollutant, should really say POL instead of pol. POL for the pollutant, that would be the pollutant code. So is this data record for CO? Is it for NOx, NH3? That would be the pollutant column. FIPS being the state and county code. Animus being the annual emissions. Now, in different formats, different data set formats, some of these column names would be different. So you might, instead of seeing and emis, it might be and value. Or if you've got monthly emissions, it might be March emis. So your row filter needs to work with the columns that are in the data set you're currently working on. And then we saw an example of the substring function. And there's other functions because this is SQL. So you can use other functions. So one thing that I ran into is I needed to use the lower function. And the lower function converts values to lowercase. So this was an example, which I'll get to in a second, where I was trying to find, I was trying to match records by a plant name, and all of the plant names were capitalized. And so I thought, oh, well, what if you've got some data that is capitalized and isn't capitalized? How would you match it up? And so you can use the lower function to convert everything to lowercase, since you wouldn't have to worry about it. There's also a corresponding upper function, which converts the column to uppercase. So then what kinds of operations can we do? So we've got all this data in columns. We know which column we want to look at. And so then what can we do with it? Well, we have a lot of options. And so you have your basic things like equals, which is an exact match equals, a not equals, meaning it does not match the value you're giving it. Then you've got numeric functions like greater than, less than, greater than or equal to. We already saw the like function, which is a wildcard matching. So this is where the data is similar to, it matches a wildcard. You also have the opposite, which is not like. So we saw an example where we said FIPS is like 37% sign. So that's really saying the FIPS code starts with 37. We could also say FIPS not like, and that would basically flip the row filter around. And that would only show us the rows where the FIPS isn't starting with 37. So the not like is the same as not equals. Then we also have a couple of operations like in and not in. And these allow you to check for a list of values. So instead of having to say SCC equals this exact value and SCC equals this other exact value, you can use the in operator and then you give it a list of values you want to match against. So the types of values that we can have a string in quotes, and it can be single quotes or double quotes. I tend to use single quotes just for consistency. I do want to mention that string is case sensitive. So if your plant names are all in capital letters, your string would need to be in capital letters, unless you do something with the lowercase function to convert the plant names to lowercase before you do your comparison. The value could also be a numeric value, like we were looking at the annual emissions being greater than 1,000, or it can be a list of values. And so here's an example of some possibilities for values. So here's an SCC code that's in quotes, so this is an exact string that we're going to match. We also have one that has a wildcard, so we would use this with the like operator, and it would say, find me SCCs that start with these 4 digits. This is just an example of a numeric value, 100.5. It's not in quotes because it's an actual number, not a string. And then in the parentheses here, everything, including the parentheses, is this list of values. So you would use this with the in operator. You could say FIPS, substring of FIPS in this list. And so you do need the parentheses and the commas because you're actually defining a list. So we've talked a little bit about the wildcard character for string matching. And so this example here, SCC like 2102% is going to display all the rows where the SCC begins with 2102. Similarly, we could put multiple wildcard characters in. And so this says plant like $Dover $. That's going to display rows where the plant name contains Dover, because we're basically saying, oh, it can have anything. You know, we got the wildcard character, then I want to see the word Dover, then anything else. So this will just be a generic contains. If the string has the word Dover anywhere in it, this will match it. Now note, this is case sensitive, so it would only match plants where the word Dover is all in capital letters. So that is the general overview of these row filters. I'm going to go back just 1 second to these examples. So again, we talked about how you give it the column name, which in these examples is SCC, FIPS, and annual emissions. You give it an operation, which could be equals for an exact match, like for a string match with wildcards, or greater than or equal for a numeric comparison, and then you give it the value that you want to check against. So SDC exactly equals this string, or the FIPS is like this string with the wildcard in it. So now it's poll time to see if this has sunk in or not. The question here is, which of these row filters is going to match our CO emissions for SCCs that start with 22? And Julie, I don't know if you have this. Oh, there we go. Yeah, so let's talk about each one of these options in turn. So this first one, well, it looks pretty good, except that an emiss is probably going to be the column for the actual emissions value itself, not the column for the pollutant code. So that would only be, that one doesn't really make sense because we wouldn't be matching CO records because we would be looking at the wrong data. B is actually really, really close. The slightly tricky thing here is we're going to match pollutant codes that are like CO, meaning that they start with CO. So that should match our CO emissions. But if our inventory contains CO2, it would also match those. So that's probably not quite what we want. In C, C is looking good, except that it's got the or joining instead of the and. So that's going to match emissions where the pollutant is CO or the SEC, it starts with 22. So that's going to give us more records than we really want. D. D is looking good. We have the right columns for the pollutant. We're going to find the pollutant is exactly CO. We got an and. Then we get to SCC, and we have an equal sign. The equals is an exact match. So what that means is we are going to look for the SCC code being exactly the string 22% sign. So the percent sign there doesn't get used as a wildcard character. This is an exact match. So we're not going to have any SCCs that are exactly 22% sign, because that doesn't really make sense. You would only use the percent sign with the like operator. You wouldn't use it with equals unless you really did have some data like a plant name or something that really contained the character percent sign in the data. So the best answer is E, where we're saying the pollutant is exactly CO, and we want to pull in this second criteria, which is that the SCC is like, starts with 22, and then we use the wildcard character to say the rest of it is we don't care. We just care that it starts with 22. So I mentioned that you're going to run across these row filters in a lot of places in the EMF because there's an underlying database, and so that gives you a really powerful way to view and work with your data. So these are just some examples of where you'll come across it. And we haven't talked about a lot of these yet, but we will. So, viewing and editing raw data, that's the interface that we've been talking about. You also may have seen it when you export a data set. When you go and do the export, you have the opportunity to type in a row filter, and so then you can export only the pieces of data that you want as well. So if for some reason you needed an inventory just for your state, you could go into the EMF, find the national or regional inventory of interest, and then enter a row filter on the export to restrict it to just your state. Similarly, when we get to talking about the QA steps, which is very, very soon, you can also use this same kind of row filter syntax during the export. And you'll also come across it when you set up QA steps. You may have seen this, we talked about the advanced data search back in the first webinar, and so this is a way of finding data sets by more sophisticated things like by description, you can match by project and things. It has a feature where you can find data sets by data values, and you use the same row filter syntax in that search. So if you want to find data sets that contain data about specific SCCs or for specific locations, you can use the advanced data set search with this row filter syntax. And then coming up in our next set of webinars, we'll be moving in to talk about control measures and control strategies. And you'll see this same kind of syntax being used when you're setting up control measures and control strategies. So I just had one more brief thing that I wanted to mention about the raw data before we move on to the QA steps. And so you've had some experience now poking around, looking at these data sets and looking at the raw data. And so if you actually need to edit raw data, there's a couple little caveats to talk about. So when you go to edit a data set, from the dataset manager, you pick the data set, and then there's an edit data button that you click. And that will open a window called the dataset versions editor. And I have a screenshot of it here. Now, this is actually a dummy example that I set up to give some versions, but you might encounter something like this. In this data set, we have 3 different versions of the data. So the initial version is always version 0. And this is the version that gets created when the data was first imported from a file on disk. That data set is always going to be marked as final because it represents the data as they existed in the import, when they got imported from disk. For this example, I had created another version, which was my 2013 additions to the file. And I used that, I made my 2013 edits, and then once that was complete, that version got marked as final as well. So now, if I want to make edits to this file, I need a version that I can work on. I need a version that's not final. And so I have my 2014 additions version, which is not marked as final. So that version is open for editing. I can make changes to it. Once a version is marked as final, then it's not editable anymore. And this is for data and analysis reproducibility. Basically, when you set up analysis steps, you want to know what version of the data the analysis was run for. And so if it's run on a final version, you can be sure that nobody has been able to edit that data. So your analysis would give you exactly the same results because the data could not have been edited. So what if we wanted to edit this and we didn't have that 2014 version? We only had final versions, but it was now time to start making some more changes. Well, you need to have a version that's not final in order to make edits. So in that case, you need to create a new version of the data set, which is what this button down in the lower left-hand corner can do. And on the next slide, when you click that new version, you get a little pop-up that lets you create your new version. And so you would give your version a name. And then the other thing that you do is every version has a base version. So basically that is saying, oh, I'm going to create my 2014 editions, and I want to use my 2013 editions as the base version, as my starting point. This allows you to have branching in your version history. I could set the base version to be the initial version, and then I wouldn't have any of my 2013 editions. There's not really a good way to merge your changes if you do start branching your versions, so it's probably best to stick with just straight linear versions, which probably fits your workflow anyway. You know, you're making additions for a particular project, and then once that's done, any future work is going to want all of those additions anyway. There is one other option, which is at any point in time, you can take any version of a data set and copy it to a brand new data set entirely. So if you've made a whole bunch of changes to a data set, it's got lots of versions, and now you just want to have a nice clean copy, you can copy any version to a brand new data set and start fresh with it. But it would have all of the changes. The actual process of editing the data is pretty straightforward. The interface is a lot like the viewing interface. It's just that then you would actually be able to type in changes to the data. We're not really going to cover that because my understanding is that you won't necessarily be making changes to like the EPA and Marama data sets, so that editing might not be such a big deal. So now I want to move on and get away from the world of data and into the world of actually doing something interesting with the data. We've talked a lot about all these data sets. We've got all these data sets loaded in. There's lots of data. What can we do with it? We want to analyze the data. So what we're going to talk about next is QA steps. And QA steps is a generic term in the EMF, quality assurance step, but it lets you perform different types of analysis on data sets. So we'll start by looking at how you can summarize the inventory emissions by all kinds of different metrics. So whether you want a summary by geographic region, FIPS code, state, you want summaries by SCC, summaries by plant, we'll look at how you can create those kind of summaries. QA steps can also let you do things like compare multiple data sets to each other, and so we're going to see an example of that. And then we'll also see how you can export the results of these QA steps, these reports, these custom reports that you're creating. You can export them as CSV files, which are spreadsheets, so then you can take them into Excel and do whatever other kinds of analysis you want to do, or plots, or whatever else you're familiar with. or you can export them as a KMZ file, which is a special file that can go into Google Earth for visualizing your data on a map. And we'll see an example of that as well. So to get started with data sets, the first thing that we need to do is be able to see the data, the QA steps on the data set. So you've already seen the properties of the data set quite extensively, and we talked briefly about the QA tab on the dataset properties window, and we'll see a screenshot in just a second. One important note about QA steps is you have to be editing a data set to actually add, edit, or run a QA step. So if you really want to work with the QA steps in terms of creating QA steps or modifying them or running them, you're going to be editing the data set. If you're just viewing the data set, then you'll be able to view all the QA steps that are associated with the data set, and you'd be able to export the results. And so just as a reminder, only one user can be editing a data set at a time, but anybody can view the data set. So as you get in and, if there's a lot of competition or, a lot of people are trying to work with the same data set, you may just have to be a little bit patient as people are setting up their QA steps and running them and then closing, leaving editing. Okay, so I talked about how we have the QA tab. So this window on the left here is the Dataset Properties Editor. We've talked about the Summary tab and the Data tab. You've gotten to see all of those different tabs. So now we're going to start talking about the QA tab. And so in this screenshot, we're listing the various QA steps that are associated with this particular data set. And we're going to see an example of what a QA step really is, because I think that's the best way to sort of understand what these QA steps really are and what they can do. But just to get you a little bit of orientation in this QA tab, basically you have the list of the QA steps. So this data set already has 4 different QA steps assigned to it. Each row here will show you the summary of the QA step status, and we're going to talk about sort of the life cycle and status of QA steps in just a second. And then you've got some buttons at the bottom here that allow you to work with the QA steps. So you've got buttons to add new QA steps, either from a template or a custom step, which we'll explain in just a second. Buttons to edit QA step, copy an existing step, which you can then edit. We'll talk about deleting in a second, and we'll talk about status. We'll talk about all of these in a second, but that's basically the overall layout of the QA tab. Now, if you are in the QA tab and you don't see these buttons, you don't see the buttons to add steps, all you see is a view button, then that means you're just viewing the data set, not editing it. So you can view the details of a QA step, but you can't add QA steps or make any changes. Okay, so now I'm actually in an example of a QA step. So just to show on the previous slide how I would have gotten here, from the Dataset Properties tab, I would have clicked on one of the one of the QA steps to select it, and then click the Edit button to bring up the editing dialog. So this is the editing dialog of a QA step, and there's a lot of pieces because QA steps can do a lot of different things. So we'll just go over some basics of this example. So this QA step is called Summarize by SCC and Pollutant, and it's working on an inventory. So what we're trying to do is we're going to try to get a summary of the inventory by SCC and Pollutant. This second line here shows us what version of the data we're working on, which in this case there's only one, so it's just the initial version. And then this pull-down menu here tells us what type of QA program we're actually going to run. Now, for the most part, a lot of the QA programs, we're going to talk about 2 different ones. A lot of the reports you're going to generate are just going to be SQL QA programs. So what that means is when you run this QA step, it's going to run a SQL query on the data to be able to generate the report for you. And in fact, the arguments here is the arguments to the QA program. So the QA program is SQL, and the arguments is the actual SQL query that it's going to run. We won't talk about that quite yet in terms of what that actual SQL query is doing. But in general, what it's going to do is it's going to sum up our annual emissions by SCC and pollutant. And the rest of this data is metadata about the QA step, which we'll get to in a second. But now that you see what the QA step does, okay, it's supposed to give me a summary by SCC and pollutant. So what does that summary look like? So after the step has been run, and we were going to look at the results, I just want to quickly show you the results. This is an example of the results of the QA step. And don't worry, we're going to go back and talk about all these details. I just want to give you an overview of the process. But this is the example of our results. And so basically, this is our report. And just like we said, we wanted to get annual emissions summarized by SCC and pollutant. So what that did is it just summed up all the annual emissions, and then our report lists out all of our SCCs and all of our pollutants, and there's our annual emissions. The actual columns and the data that's in this report, that's all determined by that SQL query. That's what makes the different QA steps do different things, is the SQL query. And then this report can be exported as a CSV file, which is comma separated values, and then that can be opened in Excel or any other spreadsheet program that you have. And we'll see an example of that in just a little bit. So these QA steps, they have a sort of life cycle to them, because there's things you need to do at each step, basically. So you first would create the QA step, and there's a couple different ways of creating these steps. You can add them from a template, which is the easiest way, and we'll talk about the templates in just a second. You can create them custom, which is from scratch. So in the case of like a SQL-based QA step, you would actually write the SQL query that you want to run. You can copy an existing step, which can be really handy if you are wanting to modify a SQL step or something. Then you can copy an existing one and just make changes to the SQL instead of having to write it all from scratch. Once you have a QA step created, then you need to configure it. And configuring it means setting the dataset version, setting up the QA program arguments, which in the SQL case is the actual SQL query. There are different QA programs which we'll see, and they use a different set of arguments. So that configuration is when you set up all of the details of the step. Then you actually need to run the step. You've created this step. It's ready to go. You need to run it. And when you run it, the EMF server is actually going to execute the underlying QA program, which could be the SQL query or different programs. And then it's going to save the results to a table in the EMF database. So it's going to run the program on your data set. It's going to crunch the numbers. It's going to put them in a table in the database. And then you're able to actually view those results. And so we just saw an example of viewing the results directly in the EMF client. You also have the option to export those results to a file, which you can then take into Excel and do other stuff with. And then there's an optional step, which is to delete the QA step when you're done. So you can imagine, like, you've got an inventory, and there might be some standard analyses you want to do on it. And those analyses, like summarizing it by state or county, those are generally useful to everybody. Other people might come in and they'd be like, oh, look, there's already a summary here. I don't need to create my own QA step. Because the results were saved in the database, they're available for everybody else. On the other hand, you might do some really custom stuff where you're trying to tease out some, really minute detail of the data. In that case, you might do the QA step, do all your analysis, and then you might be done with it, and so you might opt to delete the QA step. That deletion is permanent, when you delete a QA step, you'll get a confirmation dialog saying, "Are you sure?" But once you say yes, it's permanent. All your configuration, all the results are removed. And then one little wrinkle here is it looks like anybody can delete any QA step. I did some tests, and it looks like it's not restricted to whoever created the QA step or an administrator. It looks like pretty much anybody can delete any QA step. So if you are doing deletions, just be really sure about what you're doing. And again, you will get prompted with a confirmation that, yes, you really do want to delete this. So we just talked about sort of the life cycle of the QA step. And so the EMF stores some status variables, status information about the QA step as it moves along. So when you first create it, it automatically gets set to not started. Then once you run the QA step, the EMF will automatically change the status of the overall step to in progress. At that point, you can review the results, and once you complete your review, you manually set the status to complete. This is because the EMF has no idea what you are planning to do with the results, what kind of analysis you need to do, if you need to do some kind of iterative thing where you're going to run it, tweak the QA step, run it again, whatever your review might be. And you also have options where you can set the QA step to skipped if you decide it wasn't worth it, or you can set it to failed if you did the analysis and you said, oh, this is not good. You can mark it as failed. These statuses are for your convenience. The EMF, it's going to automatically set them to not started and in progress, but anything beyond that you manually set, and so it's a convenience thing for you to keep track in your work of what the status of these things are, so that when you come into the QA tab, you can see, oh, okay, yeah, I've completed all of these, I got some here, or maybe your colleague did some stuff and now they need you to come in and review it. That's what the statuses are for. It's for collaboration. Okay, so we just talked about the life cycle of the QA steps. So again, creating these QA steps that can create us custom reports. And so the easiest way to get started with QA steps is to use QA steps that come from a template. And basically what these templates are is they're predefined QA steps based on the dataset type. So these are things that can be managed by the EMF administrators, which in this case is Susan. And so these are different templates that apply to the dataset type. So these are some sort of standard QA steps that are applicable to the type of data, which is defined by the dataset type. So if it's an emissions inventory or some other kind of file. And then also apply to the format of the data. Like the FF10 versus the ORL format, those two inventory formats, they do have slightly different columns in them. So your SQL queries might be slightly different between an FF10 and an ORL inventory. So these templates are defined based on the data set, and they're ready to go. So on this next slide, I've just listed a handful of the templates that are available for the dataset type ORL non-road inventory. So for ORL non-road inventories, these are some of the QA templates that are available. And these are all using SQL QA programs, so these are all going to run custom SQL queries. Anything that you see with the word summarize in it is pretty much going to be it's going to be a SQL query. That's not a hard and fast rule or anything, but just generally what you'll find. So what these are going to do is each of these, if you ran it as a QA step, they would give you different kinds of summarized output. So for example, summarize by pollutant is going to give you a really, really high level summary of your inventory data. Perhaps a useless summary if if you have a national inventory and you just get one number for CO across the entire inventory. But you can see if you have a state level inventory, then a pollutant summary could be useful. You can break it down. I'll talk about the descriptions in just a second, but you can get more specific, like summarized by SCC and pollutant, or summarized by state and pollutant. There's other ones like summarized by state, SCC, pollutant, all the different combinations you can think of. They may not all be in there as templates, but we're going to see how you could take a template query and tweak it to your own purposes later. But the templates are a great place to get started. Now, these descriptions, what it means when it says with description is that in addition to the data value, like the SCC code, the description is going to give you the long description of the SCC. So there's a reference database built into the EMF that includes names associated with pollutant codes, CAS numbers from the inventory, SCC codes, FIPS codes. And so these reports with descriptions are going to join over, they're going to pull data from those reference tables. And so then your report will have a lot more records in it because it'll have, not records, columns. For each record, you'll have additional columns that are the descriptions. And then one really cool thing is if you're doing something with a state or county report and you include descriptions, then that's going to include the latitude and longitude coordinates of the county, for example. It'll be the centroid of the county. And so that report you can directly export and then go throw it into a GIS program or into Google Earth to be able to visualize the data on a map. Similarly, if you're doing something with plants, plants with descriptions will include the lat-long coordinates of each plant so that it makes it easy to take your report and go visualize it. Okay, so now we're going to run through actually creating a QA step from the template. And so to get started, we have, when you're on the QA tab, you would click the Add from Template button. And I want to see if I can bring up, hopefully you're seeing my EMF window here. Okay, so I have located a data set of interest. I used a wildcard in the name contained, so I looked for things that had 2007 area. So this is actually the 2007 area inventory. So in the dataset manager, I selected it and clicked edit properties and then switched over to the QA tab. So that's what this window is here. And I have all these windows open in advance just because then I'm not waiting for the data to load. So I'm cheating a little bit. So if I clicked add from template at this point, then I bring up this add from template dialog, which lists the various QA steps that we can add. And there's a lot of them here. The ones we're interested in right now are the summarized ones. So if I said I wanted to summarize by SCC and pollutant, I can click that. A little tip is you can click multiple ones if you wanted to, if you knew you needed a couple at the same time, you can hold down the control key and can click on multiple ones. But we'll just go ahead and grab SCC and pollutant for now. So now, back in my QA window, I already had a bunch of QA steps in here, so it's not the best example, but this line here, summarized by SCC and pollutant, that is my brand new QA step. And so we can see that the name automatically got set by the template that's set summarized by SCC and pollutant. The overall status is not started, and there's columns for the run status, and so the QA step hasn't been run yet because I just created it. And then this table will also show you more details about the QA step, like the fact that it's using the SQL QA program that's going to run a SQL query, and then the actual SQL query that it's going to run. At this point, and this is the beauty of the templates, is technically this step is ready to run. I could select it and click the run button, and it would run. But we want to actually get in and have a look at what it is really doing underneath. So I'm going to go ahead and click the edit button to bring up the step details. Yes. Okay, so final in terms of database versions means that you can't make any more edits to the version itself. But you can, a final version can be exported, you can run QA steps on it. It basically means that the data has been finalized. But right, the underlying data, but you can continue to work with it. And you can also run QA steps on non-final versions of data sets. So if you're doing some work like that, you could do it. It's just that the final kind of guarantees you that the values haven't changed since you set up your QA step. On any version of the data set, yep. Okay, so I'm switching back. The slides, by the way, just have these same screenshots in them, just in case anything went wrong with showing you this stuff. So this is what we were just talking about. The status of the QA step has been created, and now we're into the editing part. And so I'm going to switch back over here to the live edit window. And while I'm in here, let me just minimize a couple of these things to keep them out of our way. Okay, so this is our brand new QA step. And all of the fields in here were automatically populated by the template. And so we don't actually need to do anything. If you maybe didn't pick the right version, you could change it. I only have one. If you needed to give it a different name, you could do that. You have the option to enter a little description if you want to describe what you're doing, or comments about running the step. But other than that, it is ready to go. So I'm just going to go ahead and run it, and we'll see what happens. When you start the run, you'll see this note at the top of the window that just says, oh, hey, your run has started. Please monitor your status window. And so while it's running, which won't take very long, but I'll just switch back here for 1 second. So we just started the run. And so what does it mean when it's actually running the QA step? So we know there's a SQL query that needs to be run, and so that is being farmed off to the server right now, and it's running it. The server is going to be processing that step, and so you got that little message. And then once it finishes, your status window, which we'll go back to, which will show you that the step is complete. So this is just a screenshot showing exactly what we just saw, that you get that little message, and then you'll want to check your status window for your status messages. And how long it will take just depends on how complicated your step is. If it's a really complicated query running on a lot of data, then it can take longer. If your data set is very large, then it'll take a while. And then also if there's other things going on the server, like if other people are running a really big complicated QA step at the same time, then your step might take a little longer. In the meantime, let's go take a look at our QA step. So I am going to pull up my status window again. And I ran a couple QA steps earlier, so this is going to be a little bit confusing. But basically, this is what we're looking for. It's a little before 3 o'clock here. So we're looking at our message types. And here's my message that says it started running my QA step, and it finished successfully. Now, you can run multiple QA steps at one time, and so your status messages here will always include the name of your QA step, so that then you'd know which one finished, basically. So if we come back here, I'm going to go ahead and refresh this so that I can load in the newest data from the server. And so what's going on here is now we see our QA status has been set to in progress because we actually started running the step. I got set as the QA user and the date because I ran it. And then also we have the run status and the run date set, which is success because it worked, and the run date is just right now. So then we can go ahead and pull up our results. And while that didn't take hardly any time at all, but let me just Move through our slides again. Again, this is just what we talked about. And now we're looking at the results again. So we'll go back here. So I just pulled up the results of my QA step. And in this QA step, I was summarizing by SCC and pollutant. So as we would expect, I have records that are summed up by SCC and pollutant. This summed over the entire inventory. So this inventory is actually several states. So I'm just getting total SCC, I'm getting total records by SCC across several different states. This interface here for viewing stuff should look kind of familiar to you. It has a lot of the same options for sorting. So you can click on the headers and you can sort things. So I just sorted everything by pollutant and click it again to reverse the sort to get all my COs up at the top. We also have buttons for bringing up these more complicated sort options, the sort columns dialog, also the filter, lets you do filtering. There's some specialer, that's not a word. There are some additional options in here as well that would let you bring up the top largest rows, for example, so you can tell it which column you want to look at, and it'll limit it to the largest rows. The button next to it shows you the bottom rows, so you got top rows, bottom rows. There are some options for plotting, which turn around and use the R statistics software package, which you may or may not have installed, so I'm not going to talk about that one too much. It's probably more likely that you're going to want to grab this data and go ahead and export it so that you can use it in Excel. So let's go ahead and do that. Oh, those buttons are, they're part of this view results window. So this is a special window for viewing the results. And so these buttons only show up when you're viewing data results. Okay, so if we go back to our edit QA step, we want to export the data. Now, as with everything you guys do, you'll always want to be downloading the result file to your local machine. You can also optionally set the export name. So I'm just going to go ahead and say, I'm going to call this SCC pollutant port, something like that. And then I'm going to click the export button. And I have some options here when I go to do the export for like filtering the rows. And this is exactly the same syntax that we talked about before. And in fact, you were probably seeing the little tooltip pop up that says, oh, it's a SQL where clause. So this is that same row filter syntax. I am not going to put any filter on, so I'm just going to go ahead and finish that. And at the top of my window here, we see the started export for downloading. Please monitor the status window. We'll go refresh our status window. When you do the export, what's going on here is it's actually creating a file on the EMF server, and then it's going to automatically start downloading it to your computer. So that's where you see the starting the export, completing the export, and then the file will start downloading. So we'll switch back over to the downloads window, and here is my file, and this is a very small file, so it takes no time at all to download. So it's 100% complete. I can right-click on this record and say Open Containing Folder. And at this point, I'm over in Microsoft, I'm back in Windows, and here is my report, my SCC pollutant report. Now, I do want to mention a couple things here. By default, it's downloading these things into a temporary directory. This is my home directory, app data temporary. There are certain disk cleaning programs that will go through and clean out temporary files. These are temporary files. They're kind of assumed not to be permanent. So when you do these downloads, you will want to, if this is a file you want to keep, you'll want to move it to someplace else on your computer, your documents directory or whatever. So just be aware of that, that certain programs might automatically clean these directories for you. Okay, but then this is a CSV file, and I have Excel installed, and so if I click it, ta-da! is very exciting. We now have the report in Excel. And so now you can do whatever kind of analysis you would do, graphing, charting, whatever, you can do it in Excel. So let's just run back. There actually is a way. Let's see if I can bring this up because that's a good question. Okay, I'm back in Windows. In your, wherever you installed the EMF client, which will probably be like EMF something. My setup's a little different, but where you have your the file to launch the EMF client, there's a file called EMF prefs, and inside that file there is parameters. A lot of these don't impact anything, so you may see strange things, but you don't have to worry about it. There's a parameter that sets what the local directory is. I don't remember off the top of my head what that is. It's listed in the user's guide, I believe. I want to say it's something like, oh, in fact, it is local.temp.dir. So that is listed in the user's guide. But you could do something like local.temp.dir equals C colon, wherever you'd want to put this on. I can't remember Windows structure, but you know, if it's something like documents, EMF, something like that, then it should automatically download things into a different location. But by default, it'll use that. It'll use a temporary location. Oh, no problem. Okay, so we looked at the QA step results. We exported them. I showed you what the status window looks like and how it works in downloads. And we saw that the file just is on disk, and we talked about the cleaning up tool, and we just talked about how you could change that temporary location actually. One thing to mention is I typed in a name when I did the export, and so that's the name that got used. If you don't type a name, then you'll get an auto-generated one. So these other files that you might be able to see in here that are like this QA, DSID, I think those are the auto-generated names. So just something to be aware of, what the names might come out to be. And then we opened it in Excel. And so that is the basics of running a QA step from a template. You can basically go in and you have these set up queries for different data set types. So we looked at an ORL non-road inventory, and all I needed to do was say, I want to add it from a template, pick the summary that I wanted, which I picked SCC and pollutant. It created the QA step, I clicked run, and it ran it, and then I had that summary. And you saw that there were different kinds of summaries. So we can get summaries by state, we can get summaries by county, summaries by plant, not in the case of an ORL non-road inventory, of course, but for other types, there are other kinds of summaries. So that is the quickest and easiest way to get started with QA steps, is to use these ones from the template. And as part of your homework, you will have a chance to try that out for yourselves. So, I think we might skip over questions if there's not any right now, so that I can go on to the comparison stuff, because I'm running a little bit behind. Okay. Sure. So we talked about the SQL stuff, and we're actually gonna, hopefully there'll be time to go over a little example where we make our own custom SQL query. But instead I want to switch gears and talk about a completely different type of QA program. So rather than a SQL QA program, there's a QA program called Compare Datasets. And this is a really, really handy program that lets you compare datasets so that you can see what's different between different versions. So in this little example, and again, this is in the user's guide, and you'll have a chance to try this out in the homework. So if we go through this a little bit fast, there is more information. You we're going to use the compare datasets program to compare a January and a February version of the non-road inventories. We've got some monthly data, and so we just want to compare the January to February versions. So the way the compare datasets works is we give it a base dataset and a comparison dataset, and you can actually give it several. You can grab several different base. It'll combine them to compare to the comparison. So that's handy if you have inventories that are broken up by sector. So this is actually part of the homework, is you've got a single 2007 inventory, but then you have sector-based 2011 inventories. So you'll use the compare datasets program to be able to compare 2007 to summed up versions of that 2011 data. So then the way the compare datasets works is we are going to aggregate, we're going to sum up the emissions, and then we're going to compare them against each other. And so we're going to be able to specify how we want to sum up the emissions. So in this case, we're going to sum them up by, I think it's SCC, we'll get there in a second. But we're going to sum up the emissions, and then we can compare them between the two data sets. We are going to be doing an example where our data sets are exactly the same type. So that means that all the fields, the names of the fields, are exactly the same between the types. But in the homework, you'll have an example where you're going to compare ORL to flat file, and some of the field names are different. And so there's mapping options that let you say how to compare the different fields. It stands for 1 record per line. It doesn't really stand for anything. It's just, it was an intermediate format before FF10 came along, where each record in the inventory just has data for a single pollutant. So when we're setting up these comparison data sets, this comparison QA step, one of the first things that we have to do is we have to know which data set we want to use. We have to associate a QA step with the data set. This was really easy when we were doing a summary of an inventory, because of course the QA step is going to go along with the inventory. But when you're doing this comparison, the EMF doesn't specify which data set the QA step should be associated with. So you have to pick one, and this is a convention thing, so it really comes down to whatever works best for you. In this case, we are going to set January as the data set. We're going to associate the QA step with January. And again, this is important because when you want to find that QA step again, you need to know which data set it was associated with. So this is a picture of the dataset manager where we found our January inventory and we've selected it. So then we're going to go in and edit its properties so we can set up the QA step. So we went into the properties, we picked the QA tab, and instead of doing an add from template, we're going to go ahead and add from custom. Add custom. So when you do a custom data set, you have to specify everything. So you don't get to pick from a list of templates. You are going to pick, you're going to enter the name of the data set, and, the QA step. You're going to enter the name of the QA step, and then you're going to pick which program you want to run. And so in this case, we're going to go ahead and pick the Compare Datasets QA program. There are other programs in here. A lot of these are designed to analyze outputs from emissions modeling processes, like comparing raw inventories to output reports from smoke, for example. So those wouldn't be relevant to purely emissions analysis. So on that previous slide, you set the QA program, and then you click OK to go ahead and add the step. At this point, because it's not from a template, we have to set up the parameters to use. So we're going to select the step and click Edit to go in and start editing it. So we need to set up the arguments to compare data sets. And so the arguments field here, there's a Set button. And so we're going to click the Set button to bring up a special dialog for setting the arguments. There's a lot of arguments to compare data sets because there's a lot of different pieces that need to come into it. You need to tell it which data sets you actually want to compare. That's your base data set and compare data sets. You need to tell it how you want to compare the information. We talked about how we're going to aggregate, we're going to sum up the emissions. So we need to tell it which field we want to sum, which will be the annual emissions. And then we also need to tell it how we want to do the aggregation. Do we want to compare summed emissions by county? Do we want to do them by state? What level do we want to compare at? So we start by setting up the data sets, and there's an add button for both the base and the compare to pick which data sets. So when you click that, then you'll get a dialog pop up that lets you pick the data sets. And so by default, it's going to be showing you the ORL non-road inventory. That's because we associated this QA step with an ORL non-road inventory. You are not limited to that data set type when you're doing comparisons. It's just it's a handy thing. So this shows us finding our January inventory, because that's going to be our base, and clicking it. You do have some options here. If you have a lot of data sets, you can use the dataset name contains to filter your list. Again, you can change the dataset types to show other types. You do that same process for the base data sets and comparison. So we went in and picked the January as our base data set, and we're going to compare it to the February data set. You also have the option to set which version you want to use. These both only have initial versions, so we're good. If your data set had multiple versions, then you need to click the set version, and you'd be able to pick which versions you want specifically. You're going to get the default version automatically selected. We talked about this, I think, last time, that there's a default version of data sets, and so that's what each data set has a version that's tagged as the default, and so this is one of the places it would be used. So now we have to talk about the group by and aggregate expressions. So we know that we want to compare the summed emissions by SCC and pollutant. And I think I misspoke earlier. I think I said annual emissions. These are monthly inventories, so we're actually going to be comparing average day emissions. So we're going to compare the summed average day emissions by SCC and pollutant. So the field names that we need to know for this non-road inventory data set are the column that contains the SCCs, which is SCC, the column that contains the pollutants, which is POL, and the column that contains the average day emissions, which is AVDAY emis. You can find these columns out by looking at the raw data, like we were doing before at the very beginning of this webinar. We were viewing the raw data. Those are the same column names. And I mentioned how we don't need any matching expressions because all of the field names are going to be the same between the base data set and the comparison data set. So we don't need to worry about explaining to the EMF how to match the data sets to each other. So then this screenshot shows how these fields get filled out. So the group by just tells us which fields we want to group by. So we're going to group the values by SCC and then by pollutant. And then the aggregate expressions tells it which emissions column we're actually going to aggregate. We're going to sum up. And that is all we need for this because it's a pretty simple case. We don't need any matching expressions. We don't need to do anything fancy. There are options here, like you can set the where filter. It's that same row filter syntax. You can use that same syntax to restrict which records from the two different data sets you want to compare. And again, this is part of your homework, so you are going to go in and set one of these up yourself, and you'll be able to see what these different options can do. So on this previous page, once we were done, we clicked OK to go ahead and save our arguments. And so then when we come back to the QA step, our arguments are populated. The arguments to this program are actually a string of commands. But the dialog, using the set dialog, makes it easier to enter them without having to try to type stuff directly in. At this point, this QA step is ready to run because we've set all of our arguments up. Running a custom QA step is identical to running the step from the template. It works exactly the same way. You're going to start the run. It's going to run on the EMF server. You check the status window. You can export your results exactly the same way, view the results exactly the same way. So I do want to quickly show you the results of the compare data sets. So this is the results of comparing January to February. So we were summing up our average day emissions by pollutant and SCC. So each record is for a particular pollutant and SCC. Then what it shows us is the summed average day emissions for the base data set, that's what the B is, versus the comparison data set, that's what C is. Then it automatically does a difference. So this is just a straight B minus, or sorry, it's C minus B to give you the difference. It'll give you an absolute value difference. It'll also do a percent difference and an absolute value of the percent difference. And then finally, it gives you a count of the number of records. And so what that count is telling you is how many records from the original data set went into this sum, and how many records from the comparison data set went into its corresponding sum. So in this case, B is for base, and then C is for comparison. And those you can actually set. That's another option back here when you're setting up the data sets. You have this base field suffix and compare field suffix. And basically that sets whether you see _B and _C, or if you see your own custom thing. So I think in the homework exercises you'll set those, and then that makes it just a little easier to understand your results. Yeah, so these count rows here, we're comparing two inventories that are very, very similar to each other. They're just the January data versus February. So the counts are pretty much exactly the same because the sources are going to be the same. But when you go in and you start doing comparisons of like different years, then those counts can vary as sources go away or get added. So the count is just sort of telling you how many records matched, how many records contributed to that row. And again, you will get to play with this because it is a very, very handy thing, this QA step, this program. So your homework, I think, will actually take you through two different examples of setting up a data set comparison. Julie, do we have time for like 5 more minutes, or do we need to finish? Okay, so then the last thing, yeah, I have just a few things left. The last thing that I wanted to talk about is the idea of customizing the SQL queries. So you saw in our example, we took a QA step, we took a template, and it had SQL in there. All of those templates are going to be based on annual emissions. That's how they all work. So what happens if you want a report of the average day emissions? Or maybe you need a summary that's a little bit different than what's already there. What you can do is you can start with the SQL from a template QA step and then customize it to make your own step. So this is an example where I grabbed a summarized by county and pollutant QA step just so that I could get the SQL query. So I'm going to pull out this SQL query and show it to you on the next page. So this text right here is the full SQL query that would be run by this QA step. Now, I know you don't have a lot of experience with SQL, so a lot of this you don't really need to worry about because we're just going to go in and change a few little things. But basically what this is doing is it's setting up, the select tells us which things we want to grab, which things we want to select. We're looking at the columns FIPS, pollutant, and annual emissions, and we're doing a sum over the annual emissions. So if we want to change this to, instead of be annual emissions, we want it to be average day emissions, we would need to change the places where we see annual emissions to be the average day emissions instead. And I do want to mention, for people who know a little bit more about SQL, there's this little $ table thing in here. That is the custom syntax that the EMF uses to match. When it's doing this SQL query, it needs to know what table to go and get stuff from. That's how it knows for a particular data set what data to get. So you don't have to worry about it. It'll just be in all of these queries that you see. So just we pulled the SQL out, and then we could revise it for our custom report. So we would replace an emiss with average day emiss. And then I mentioned that maybe instead of summing the emissions, it would make more sense to create an average of the emissions instead, because we're looking at average day. So we have the original query has a sum function in it. We could change that to the SQL function average if we wanted to. And then we would just replace the stuff in that same query. So we just changed out sum annual emissions to just be average of the average day emissions. And then we also changed out the other place where annual emissions was referenced. This query then is now ready to be used in a QA step. So you can create your own new QA step where you just paste that query in as your SQL. And then this is a QA step that you can run just the same as any other QA step. So that's kind of a more advanced topic. You may find as time goes on, you guys find new templates that you want to add, and so it may make more sense to just add additional templates so then you don't have to worry about SQL. But that is just a glimpse of the underpinnings that are there that you can see. And then we're out of time right now to go over Google Earth. The good news is we can also talk about Google Earth stuff when we start analyzing the control strategy results, which will be coming up in the upcoming webinars. So if you're interested in Google Earth, come back for that, because I will make sure that we get a chance to show that off just a little bit. It's also described in the user's guide how you do the export. So if you have Google Earth installed on your laptop, you can try out the export and try it out for yourself if you feel like it. And that is that.